Hey everybody, Mr. B here. Today we're going to talk about severe storms, and in particular, the severe weather known as thunderstorms, tornadoes, as well as hurricanes. Obviously, two of the three of those have the ability to impact us here in Wisconsin, whereas the third, not so much, with hurricanes. And specifically about each of these different storms, we're going to talk about how they form, some of the general locations in which they occur around the planet, and finally how to keep safe from some of the nastiness that kind of brews out of these different things. So while you're watching today, I'm going to need one thing from you, obviously other than your ability to add to your modeled information that you currently have, but I also want you to formulate at least one question from the video. So that is your one task here, at least with respect to this video. Now, first of all, we are going to speak on the topic of thunderstorms, which again brew out of those giant cumulonimbus clouds that we all know and love. Now, generally, those thunderstorms are going to bring about some thunder and lightning, and we'll talk about lightning here in a moment. Also, along with your thunderstorms, some of the features, or another feature associated with that, is winds. All right, winds. You can get some pretty nasty straight line winds that have the ability to, come brewing out from a thunderstorm. For the most part, in order to form a thunderstorm, you're going to need two main ingredients. And those two most important ingredients are some instability in the atmosphere or some unstable air, and you need a ton of moisture. All right, so humidity is huge, and also instability in the atmosphere as well. With respect to safety during thunderstorms is, I feel it's just as important as safety during a tornado or safety concerns during a hurricane. Lightning can be something that can be obviously very dangerous, and depending on your situation and where you're at in terms of your environment, your chances will either increase or decrease of being impacted or struck by lightning. Some obvious things to avoid would be metal objects, which are conductors, as well as tall objects. You don't want to be standing underneath the only tree in a large field. Despite the fact that that tree may be shielding you from the rain, that tree will also be a good spot for lightning to impact. And when we start talking about electricity and magnetism here over the coming weeks, you'll have a little bit more experience with how lightning is actually formed. But I don't want to get into that too much now. Next up, we want to talk about tornadoes. Here in Wisconsin, from time to time, we have some encounters with these majestic beasts from the atmosphere. Speaking specifically about their formation, generally we're going to look for these to come out of some low, heavy cumulonimbus clouds. So, along with tornadoes, generally they're going to be accompanied by some thunderstorm activity as well. For the most part, when we're looking at tornado formation, we're generally going to see these things form when cold, dry air meets warm, moist air. Now, obviously, from our talk or readings about thunderstorms, that will help create a thunderstorm as well. So, with the potential of thunderstorms comes the potential at times of some tornadic activity as well. Generally, within a thunderstorm, we can find some areas where winds at all levels of the atmosphere throughout that cumulonimbus cloud are not only strong, but they're also going to turn with height in a clockwise direction. So when we get some of that spinning within a cumulonimbus cloud, which we can actually at times view on radar, this can indicate some potential tornadic activity. Now, if we're going to compare that tornadic activity to what happens across the entire nation, generally, a couple things come to mind. Your classic buzzword with respect to tornadoes is Tornado Alley, which for the most part, incorporates kind of this area, or, I would say historically is generally going to be contained in this area right here. However, if you compare our state as a whole to the rest of the world, I mean, we're having a tornado nation of sorts. Now, granted, this particular image was crafted back in 1973 by, the great Ted Fujita, Mr. Tornado himself. However, if you just look at the tornado strikes or tornadoes from around the world that touched down in this particular year, you can see that the vast majority of them, took place here in the United States themselves. So, from your west or your Midwest area out here to the west of in the western portion of our country, I should say, to clear that up, all the way across the country to the east are all impacted, by tornadoes from north to south. And comparing that to the rest of the world, we get quite a few of them. Now, as far as tips are concerned, here are some things that you need to know before you actually need to prepare yourself, because, tornado warnings can pop up in a moment's notice. Some of you have probably heard the sirens before. I know my house here in town, the one I used to live in, was parked right next to a tornado siren, and when that thing went off, boy oh boy, it was waking up everybody. As well it should. I mean, that's what it's there for, to protect us from, these types of severe weather and get everybody safe when the time is necessary. But some general safety tips. Number one, practice and prepare. Know where you're going. Okay, you should have a place to meet your family, not only before but also after a tornado. Generally, we want to seek shelter in a basement or a small interior room in the lowest floor possible of your house. Now, if you're in a mobile home, you're going to need to get out and look for a stable building. Also, if outside you want to find low ground away from trees and cars, obviously we want to get away from trees and cars because these things have the ability to be thrown by a tornado. You're also going to want to lie face down with your arms protecting your head in case of some flying debris. After the storm can be just as important as during or before. You're going to want to stay away from those downed power lines. Also, you're going to want to avoid flooded areas because at times you could have power lines that are submerged and still live with electricity. So stay out of huge flooded spots. Now, also, you don't want to enter horribly damaged buildings because you just aren't you can't be sure of the safety of the structure. It could be compromised at any moment. And plus, you don't want to light matches or use lighters in case there are potential gas leaks in the area. All right, moving on to hurricanes then. Hurricanes, folks, are obviously very large in size. They are the largest of the storms that we are going to be discussing here today. And to get into the four main hurricanes themselves, generally these are obviously areas of low pressure that form over very large bodies of water. Now, these bodies of water, you guys, we're talking about oceans, okay? Not so much like Great Lakes or even some of the seas like the Mediterranean or the Baltic Sea. We're talking about huge bodies of water, that being an ocean. Now, the oceans generally have to reach about 79 to 80 degrees Fahrenheit before we can have an adequate amount of energy that's within. Now, if you look at what you all need to generate a hurricane, obviously number one here, we need some warm water that we just talked about. Two, you need winds coming together to force air upward. So we need some convergence to occur here. Now, once that occurs, it's going to kind of begin to pull some of this moisture aloft and into the atmosphere. Once that does get vertical in the atmosphere, the winds will flow outward above the storm, allowing the air below it to rise. So when it kind of rips the cork off the bottle here. So you're allowing more and more moisture to flow upward and begin to eventually create some storm-like atmospheric conditions. In addition, obviously, we need some humid air that's rising to form the clouds of the storm within the atmosphere. And then finally, some light winds outside the hurricane to steer it and let it grow. Because the steering winds are very, very important. These are going to obviously, get this to, somewhat take shape and move from one place to another. All right, in terms of a hierarchy here of storms and what eventually creates the hurricane, you start out with your tropical disturbance and then eventually become a little bit more organized, which forecasters or meteorologists will consider a tropical depression. Once your tropical depression becomes a little bit more organized and reaches consistent wind speeds of at least 38 to 73 miles per hour, you're going to fall into the tropical storm range. And again, we're looking at straight line, consistent wind speeds. These are not gusts. So, I mean, even here in Wisconsin, we've had gusts of 55, 60 miles per hour, at least here over the last couple of years. That does not classify a tropical storm. You need to have consistent wind speeds, which means basically you step outside and boom, you are hit by this wind. And it is constant and it's always blowing. Once we reach the magic number of 74 miles per hour, then that is going to, classify as a hurricane. Once you have hurricanes, those are categorized by the Saffir-Simpson scale, which will categorize your character or categorize your hurricanes on a scale of 1 to 5. 1 being the least severe, 5 being the most severe. The most severe storms, for example, Typhoon Haiyan, which has just impacted the Philippines greatly, eclipsed this Category 5 strength by upwards of 50 miles per hour. And we're talking about wind speeds that hit the land at 200, 220 miles per hour. That is a vast amount of wind that if you want to actually see something close to that, or at least Category 5 strength, and what that would do to a person, I highly recommend checking out Jim Cantori's wind tunnel video, which I believe I currently have on Student Center. So, it's about a 3-4 minute video. It shows you just exactly what it's like to withstand, Category 5 winds. Basically, folks, you're not going to be able to stand up at that speed. Now, what's going to make this this hurricane powerful are its parts. Essentially here, you have your eye of the storm, which within the eye itself, you will have some convergence of moisture that will kind of drive upwards through evaporation. Because again, remember, your ocean temperature here are 80 degrees and plus in some parts of the world. So, evaporation is going to take place rather quickly. And as that evaporates, you'll have obviously some downdrafts of air that will kind of carve out a hole here, which is known as the eye. When you're over, or when the eye is over you within a hurricane, it is peaceful. It can be calm at times, but that calmness is rather short-lived, because once that eye moves away and you hit the eye wall, you can have some of the more severe aspects of the storm. Plus, sprouting out from the eye itself are these spiral rain bands, which can create some significant thunderstorm activity. Check here. You can see these rain bands or the spiral bands of your hurricane, and these can also pack the most significant wind strength. Basically, some of these leading edges of a hurricane can create not only the highest wind speeds, but also the greatest amount of storm surge. Now, what a storm surge is when you take these giant areas of low pressure and these high winds, when they push across the ocean, they begin to build up water as they push. So it's kind of like if you take your arm in a pool and move it across the surface of the water. Again, you can build up a tremendous amount of water behind your arm. And that is essentially what this hurricane will do, is push water all the way from wherever it begins and throw it onto the land. And it can do so at heights that obviously eclipse whatever the shoreline has in terms of barriers. So, take Hurricane Katrina, for example. Some of those levees just weren't not only built high enough, but built strong enough to, support some of the storm surge that was coming in, and they broke or were breached. So when we're talking about walls of water, I mean literally walls of water that are 15 to 20 feet in height. Those can be especially dangerous, and at times even more dangerous than the high winds themselves. Here you get a good look at some of the tracks of hurricanes over about a 150-year span. And obviously, they all sprout out from around the equator, where we have the most direct heating on our planet, which creates the highest temperature of water, which again is essentially the fuel for massive hurricanes. All right, so to recap here, obviously we talked about some hurricanes, we talked about thunderstorms, we talked about tornadoes, and now is your time to, again, write down a question. And when you're finished writing your question and you've got your information modeled, come on and see me, and I'd love to hear from you, and we'll discuss it. So see you next time.